All right, welcome to the lecture 7.4, the other trig functions. In 7.3, we went through sine and cosine and how that relates to special right triangles within the unit circle. And so now we're going to expand that knowledge out to the other four trig functions that we will be basically studying for the rest of the semester. Okay, so finding exact values. As with sine and cosine, we can use the xy coordinates to find other functions. So, my notepad was not, my bamboo tablet wasn't plugged in. There we go. I went to write and nothing happened. My excuse is that it is 7 a.m. Okay. So we found out in the last lesson that we can replace x and y with cosine of angle t, which is the central angle, subtended by the arc around the unit circle from the initial to the terminal side of the angle. So the x value corresponds to the cosine of the angle and the y value corresponds to the sine of the angle. And we can use this knowledge to rewrite all of the 6 trig functions. So I'm just going to rewrite some stuff down here for you. So first, let's look at the sine of t. That is the same thing. Sine, let me remind you, we have so, ka, toa. Sine is the opposite, which is the y, the distance from the x-axis to the point, which is y in the vertical direction. So it's the opposite side over the hypotenuse, which is 1. So that is just y. And we also know that this is the inverse of the cosecant of that same angle. The cosine of t is adjacent over hypotenuse, and that is the reciprocal function of the secant of t. And then we have tangent, which is the opposite over the adjacent, and that is the equivalent of the reciprocal of the cotangent function. Okay, so sine is reciprocal to cosecant, which means cosecant is 1 over y, or 1 over the sine of the angle. Cosine is reciprocal to secant, so this is 1 over x, or 1 over cosine t. And cotangent is reciprocal to tangent, so x over y, or 1 over the tangent. Okay, so we'll move forward from here and start using this information. Okay, so the first thing we're asked to do here is to find the 6 trig functions for the angle t, and they even give you the corresponding coordinates of the point on the unit circle that angle t lands at with its radius there, or its terminal side. So I'm just going to set up my 6 trig functions here, and I like to keep I like to keep my trig functions and their reciprocal functions across from each other. So I always set it up. Sine t, cosine t, tangent t, and then directly across I set up their reciprocal functions, cosecant t, and this just keeps on establishing that relationship in my mind, cotangent t. Okay, so the sine of t, and this is the right triangle that we're dealing with here. The sine of t is the y value, so that is just 1/2. Cosine t is the x value, so that's negative square root 3 over 2. The tangent of t is the y value, 1/2, divided by the x value, negative square root 3 over 2. Of course, we cannot leave it this way. So the good news is we never divide fractions. We multiply by the reciprocal. So this is 1/2 times the reciprocal 2 over negative square root 3. My 2's divide out. So I have 1 over negative square root 3. I can't leave it like this. I need to rationalize that denominator by multiplying by the square root of 3 over the square root of 3. Let me actually move this over a little bit. Okay. Get my black pen back. So we multiply fractions straight across. This is negative because I've got a negative times a positive, square root 3, and the square root of 3 times the square root of 3 is the square root of 3 squared, so it's just 3. So negative square root 3 over 3. Now to get the cosecant, secant, and cotangent, all we have to do is give the reciprocal of their reciprocal function. So the cosecant of t is the reciprocal of 1/2, which is just 2. The secant of t is the reciprocal of negative square root 3 over 2, so negative 2 over the square root of 3, which I need to rationalize. Can't leave that square root in the denominator. So square root of 3 over square root of 3. And I have negative 2 square root 3 over 3. And the cotangent is the reciprocal of tangent. So negative 3 over square root 3. Once again, I need to rationalize. Square root 3 over square root 3. So here I get negative 3 square root 3 over 3. My 3's divide out. And I am simply left with negative square root 3. All right, we're going to do the same thing for this other point here, this other angle. So we have sine t, cosine t, tangent t, and then cosecant t, secant t, cotangent t. Okay, and here is the right triangle we're working with. Okay, so the sine of t is just negative negative square root of 2 over 2. It's the y value there. And then the cosine is positive square root 2 over 2, just the x value. The tangent is the y value, negative square root 2 over 2, divided by square root 2 over 2. Well, anything divided by itself is just 1. I have a negative divided by a positive there. So this is just negative 1. The cosecant have 2 over the negative square root of 2. I need to rationalize. So I multiply by square root 2 over square root 2. And I end up with, have a negative times a positive, so negative 2 square root 2 over 2. My 2's divide out, and I end up with negative square root 2. Secant, it's the same thing as the cosecant there, except it's positive. So I'm just going to go ahead and say this is the square root of 2. Because it's the reciprocal of the cosine, which is the same thing as the sine except for the actual sign itself, positive or negative. And the cotangent is the reciprocal of tangent, so this is also negative 1, because I just flip-flop those positions and divide. Is that good, Crystal? You can give me a green check if that made sense there. Okay, great. Okay, so this chart up at the top, this is included in your textbook. I included it in your notes. This just gives the function value for our special angles. Pi over 6, well, 0, of course, pi over 6, which is 30 degrees, pi over 4, which is 45, pi over 3, which is 60, and then pi over 2, which is 90 degrees. So this is basically just a chart giving you those function values for those particular special angles. So we can use the chart above to find the function values for all of these functions down here without having to do any work for it. So sine t, cosine t, tangent t, cosecant t, secant t, cotangent t. And t is pi over 3. So we're going to be looking in this column here. Okay, so the sine is square root 3 over 2. The cosine is 1/2. The tangent, square root 3. The cosecant is 2 square root 3 over 3. The secant is 2. And the cotangent is square root 3 over 3. Easy enough. Okay, using reference angles to evaluate secant, cosecant, and cotangent. We can evaluate trigonometric functions of angles outside of the first quadrant by using reference angles, as we've already done with sine and cosine. So we have a mnemonic device that helps us remember when the trig function will be positive and in what quadrant. So we can use this mnemonic device, a smart trig class. So we have a smart trig class. A means all of your trig functions are positive in that first quadrant. And don't forget, when you move through the quadrants, you always move counterclockwise through them. S means sine and its reciprocal function are positive in that quadrant. Everything else is negative in that quadrant. And you can think about, okay, so why? Why would all the other trig functions be negative in that second quadrant? Let's say we have a point in that quadrant that's going to have a negative x value and a positive y value. So remember, sine and cosecant all have to do with the y value there. Sine is the y that we find, and then cosecant is just 1 over that y value, which is not going to change the sign of it. So that's why those two are positive. Every other trig function, cosine, tangent, secant, and cotangent, all have that x coordinate involved with them. So they all bring that negative x into play. So, Crystal, did that make sense? Did that explanation of, okay, so why are sine and cosecant the only trig functions that are positive? Okay. So it's going to be the same sort of explanation for these other two. We get down to the third quadrant and see for the t there, tangent and its reciprocal cotangent are positive. And then finally in quadrant 4, cosine and its reciprocal secant function are the ones that will be positive. So we can use that acronym, A SMART Trig class, to remember which ones are positive when we move through the 4 quadrants. Sorry, my voice keeps, it's very deep this morning and it's scratchy. I went to a concert last night. Got very loud and excited, so I'm hoping my voice will last for the rest of the lecture here. Keep our fingers crossed. Okay, so how to. Given an angle not in the first quadrant, we want to use reference angles to find all of the 6 trig functions. So how do we do this? Well, we measure the angle formed by the terminal side back to the horizontal axis. So that is the reference angle we're talking about. So we basically find the reference angle. We evaluate the function at the reference angle, observe the quadrant so that we can tell whether it is positive or negative. Okay, so we have negative 7 pi over 4. Let me actually grab a unit circle for us to look at. I think this would be helpful. I've got one right here on my desktop. Okay. So if we move negative 7 pi over 4, remember negative moves us in the clockwise direction. So if we start here at a 0 angle, here's negative 1/4 pi, negative 2/4, negative 3/4, negative 4/4, negative 5/4, negative 6/4, negative 7/4. This is where our angle ends. But what we do, instead of using that negative 7 pi over 4 angle, we use the reference angle, which goes from the terminal side back down to the x-axis, because it's going to have the same exact coordinates as the angle we began with. So basically a negative 7 pi over 4 radian angle is the exact same thing as a pi over 4 radian angle. So our reference angle is pi over 4, or a 45-degree angle. But we're looking at it in radians right now. And we're asked to find the 6 trig functions. So sine, cosine, tangent, and for the sake of room, I'll go underneath with these. cosecant, secant, and cotangent. Okay? Okay, so just to make this a little bit easier to see, the coordinates of this point are square root 2 over 2, square root 2 over 2. And now think about it. We're in the first quadrant, and if we use our acronym, a smart trig class, all functions in the first quadrant there are going to be positive. So that's one check we can do for ourselves over here when we find the trig functions and make sure they're all positive. Sine is the y value, so square root 2 over 2. Cosine is the x, square root 2 over 2. Tangent is y over x, which is just 1. Okay, cosecant is the reciprocal of sine, so 1 divided by square root 2 over 2 is the same thing as 1 times the reciprocal, 2 over square root 2, which is 2 over the square root of 2. We need to rationalize. The square root 2 over square root of 2 that I'm multiplying with, and that gives me 2 square root 2 over 2. My 2's divide out, so that's just the square root of 2. Okay, the secant is the reciprocal of cosine, but cosine's the same thing as sine, so this is just the square root of 2. And cotangent's the reciprocal of tangent, so that is just 1. All right. You good to go, Crystal? Okay. Okay, using even and odd trig functions. So let me just remind you about the characteristics of even and odd functions before we look at the trig functions with this. Okay, so the most basic even function is the quadratic, which is f of x equals x squared. And any even function is going to have the property of, if I plug in negative x for x into the function, I'm going to get out the original function that I started with. In other words, none of my signs change. So I'll just show you f of negative x. When I plug that in, I get negative x squared. That negative squares away, and I'm just left with x squared. So I started out with positive x squared and ended up with positive x squared, so none of my signs changed. So that, algebraically speaking, this is an even function because of that characteristic. Graphically speaking, you will have reflection or symmetry happening across the y-axis. In other words, it doesn't matter if you plug in a negative 2 or a positive 2, you're still going to get out positive 4 with both of those. So if I put a mirror on the y-axis, because they have the same y values, you're going to mirror yourself across the y-axis with an even function. Okay, with an odd function, so moving over to the cubic here, we have f of x equals x cubed. With any odd function, whenever you plug in negative x, you get out the opposite sign polynomial, which we call an opposite polynomial. All the signs change. So this is considered odd. So if I plug in negative x here, I have negative x cubed. Well, negative x times negative x times negative x is negative x cubed. I started with a positive x cubed, and I ended up with a negative x cubed. So all my signs changed. So algebraically speaking, when you're dealing with an odd function, all of your signs change. Graphically speaking, they have what we call origin symmetry. So if you put a mirror across the origin, it's going to reflect diagonally across it. So notice we have the point 1, 1. That means when I plug in the negative of that x value, I get the opposite sign. So the point -1 also exists on the function. Is that good to remind you of what even and odd functions are, Crystal, before we start looking at the trig functions with them? Okay. Okay, so we can test whether a trig function is even or odd by drawing a unit circle with a positive. So here's our positive angle. And a negative angle of the same size. There's our negative angle. Okay, so note that when we do so, we end up with, we have the same x value, and that yields a negative y value there, corresponding to positive x, positive y there. The sine function then is an odd function. Okay, so what they're saying is sine of theta, the sine function, whatever the theta angle is considered odd because notice that you have positive y here and the opposite sign, negative y there. And we can test all of the trig functions that way. So since the cosecant is the reciprocal of sine, it's also going to be odd. So we have a chart that has done all the work for us. And this is included in your text and in your notes here. I don't want to bog down and show all the trig functions with the divisions here, but it is useful to know this this chart here. So we have our odd ones, and if you notice, our odd trig functions all have y, that y value in them. So sine is reciprocal to cosecant. And remember the tangent is y over x. So you've got that y value that's flip-flopping signs, and the reciprocal to the y value is cotangent. So the four functions, sine, tangent, cosecant, cotangent, those are all the odd functions. Cosine and secant are even because they only deal with the x values. Remember, cosine is x, and secant is the reciprocal, which is 1 over x, but that does not change the sign of that. Is that enough for you to understand that, Crystal? Like I said, I don't want to get bogged down in it, but if we need to go over it more, I can. Okay, it's not good for you. Okay, I see you're typing. I'm going to see what you have to say. Oh, sorry, wrong button. Good, it is good for you. Awesome. All right, so the secant, which we already know to be an even function, We're told that the secant of angle T is 2. So the secant of T is 2. What about if we plug in a negative angle? Well, since it's even, we know it's still going to be 2. Nothing's going to change about it. The cotangent of angle T is the square root of 3. What is the cotangent of a negative angle T? Well, it's odd, so that's going to be negative square root 3. Easy enough. And I think the easiest way to remember which ones are odd and which ones are even are any of the functions that have the y coordinate in them are going to be odd. Or you can just remember the only even ones are cosine and its reciprocal secant. Okay, so using fundamental identities here. We have already established these identities. We did that back on the first page. I'll just remind you. Oops. So we did that all here. And we could even extend these more, knowing that sine is y and cosine is x. I could call tangent, this would be the same thing as sine of t over cosine of t. So that's all this next part is doing, is putting all of our 6 trig functions into sine or cosine. Okay, so tangent is sine over cosine. Secant is the reciprocal of cosine, so 1 over cosine. Cosecant is the reciprocal of sine, so 1 over sine t. And cotangent is the reciprocal of tangent, so it's cosine over sine. And we are asked to use identities to evaluate these functions. So the tangent of 45 degrees is the same exact thing as the sine of 45 degrees divided by the cosine of 45 degrees. Now I have a really tiny unit circle down at the bottom. Let me see if I can make it a little bigger so we can actually see it. And I'll move it around there in just a second so we have room to do those other 2 problems. Okay, so 45 degrees, the sine of 45 degrees is square root 2 over 2, which is that y value there. The cosine is also square root 2 over 2. So the tangent of 45 degrees is 1. All right. Move this up over here. Now we're asked to evaluate the cosecant of 7 pi over 6. Okay. Move this down a little bit. Okay, 7 pi over 6 lives right here. And cosecant is the reciprocal of sine. So the cosecant of 7 pi over 6 is the same thing as 1 over the sine of 7 pi over 6. And let me back up for a second. The reason we want to get everything into sine and cosine is because those are the x and y values for those points. So once we know what the sine or the cosine equivalent to these things are, we can easily use our unit circle to evaluate. Okay, so the sine is the y value, so that's 1 over negative 1/2, which is the same thing as 1 times negative 2 over 1, which is just negative 2. Okay? And the secant of 5 pi over 6, well, the secant is the same thing as the reciprocal cosine, 5 pi over 6. 5 pi over 6 is right here. And the cosine is our x value. So this is 1 over the negative square root 3 over 2, which is the same thing as 1 times negative 2 over the square root of 3, which is negative 2 over the square root of 3. I'm just going to bring it down here because I need to rationalize the denominator. So I'm going to multiply by square root 3 over square root 3, and that gives me negative 2 square root 3 over 3. You good with all that, Crystal? Okay. Let me bring our unit circle with us. Oh, actually, I don't think we need it because we're just using general functions, not actually evaluating. But it's good to have anyway. It doesn't hurt to have it. Okay, so we have our identities down here. Okay, the secant, so it just says simplify this. In other words, put it in terms of sine or cosine or one of the trig functions. Okay, so the secant is the same thing as 1 over the cosine of t. And the tangent is the sine of t over the cosine of t. And I can simplify that by not dividing my fractions, but multiplying by their reciprocal. Cosine t times the reciprocal cosine t over sine t. My cosine t's divide out there, and I get, well, that's the same thing as 1 over the sine of t. And 1 over the sine of t is the reciprocal of sine, which is the cosecant of t. So what this says is the cosecant of t is the same exact thing as the secant of t divided by the tangent of t. We've just given it as one single trig function. Okay, so this next one says the tangent of t times the cosine of t. Well, the tangent of t is the same thing as the sine of t divided by the cosine of t. And I'm multiplying that by the cosine of t, and I'll just put that that's over 1. My cosines divide out, and this is the same exact thing as the sine of t. You good with those, Crystal? Very good. Okay, so looking deeper into Pythagorean identities, we established in the last section that the cosine squared of t plus the sine squared of t is equal to 1. And that just comes directly from the Pythagorean theorem. A squared plus b squared equals c squared. When we superimpose that into our unit circle, creating that right triangle, we have x squared plus y squared equals 1. Our x value is cosine, our y value is sine, so we get cosine squared t plus sine squared t equals 1. Well, if I come through and divide cosine squared t off of all of those terms, I end up getting cosine squared t divided by cosine squared t is just 1. The sine over the cosine is the same thing as the tangent, so this is the same thing as tangent squared t. And 1 over the cosine, that's the reciprocal of the cosine function, which is the secant. So I get secant squared t. So this is just giving me that same Pythagorean identity in a different form to incorporate tangent and secant. So same thing, if we come back and we divide every term in the Pythagorean identity by sine squared t, we get cosine squared t divided by sine squared t is cotangent squared t. Sine squared t divided by sine squared t is just 1 equals 1 over the sine squared of t. Well, that is the cosecant squared of t. So that gives us new forms of our same Pythagorean identity. Okay, so this next one's where we we're starting to have to do a little bit more work to pull those trig functions out. We are given at the beginning that the secant of our angle t is equal to negative 17 over 8. And we're told that angle t lives in either quadrant 1 or quadrant 2 because it lives between 0 and pi, which we know pi is that 180-degree angle. So between 0 and 180 degrees, the only 2 quadrants that you move through are 1 and 2. And I'm actually going to argue that this has to be quadrant 2 because all functions, all trig functions are positive in quadrant 1. And look, we ended up with a negative trig function here, the secant. So this has to be living in quadrant 2. Let me stop there before I get going, Crystal, and say, did it make sense how I was able to determine we're living in quadrant 2 here? Okay. Okay, so if I can figure out what my sine and my cosine values are, then I can figure out all the other trig functions from there. But I'm given my secant. So what I can do is use my Pythagorean identity that involves the secant and pull from there my sine and my cosine. So I have 1 plus tangent squared t equals the secant squared of t. Well, the secant of t is negative 17/8. And that's squared. Okay, so 1 plus tangent squared t equals, okay, let's see, 17 squared is 289, and 8 squared is 64. And I need to subtract 1 from both sides. And so I have that the tangent squared of t is equal to 289 over 64 minus 1. And I'm going to put that 1 over 1. because I need to get a common denominator to be able to subtract these values. So I multiply by my clever form of 1, 64 over 64. And now I have that the tangent squared of t is equal to 289 64ths minus 64 64ths. Okay, 289 minus 64 is 225. So the tangent squared of t is equal to 225 over 64. I take the square root of both sides to solve for the tangent. And I get the tangent of t is either positive or negative. We'll decide in a moment. The square root of 225 is 15, I think. Let's see, 15 squared, yep, it's 225. So 15 over the square root of 64, which is 8. Okay, so remember our little acronym, a SMART Trig class. In our second quadrant, the only things that are positive are sine and its reciprocal cosecant. That means my tangent in the second quadrant is going to be negative. So I don't worry about the positive. It's negative 15/8. All right, let me set up my little trig function chart here. Sine of t, cosine of t, tangent t, cosecant, secant, and cotangent. Okay, here's what I already know. I know that the secant is negative 17 over 8. Okay, before I start moving forward, I want to decide, okay, is my numerator negative or my denominator negative? And actually, it might be easier to decide from the tangent. So we know that the tangent is negative 15/8. And don't forget, the tangent is y over x. So if we think about the second quadrant, every point in the second quadrant has a negative x and a positive y value. So the negative actually goes with my 8 as opposed to my 15. Why is this important? So this negative over here with the tangent goes with that 8, which means my secant, the negative's in the denominator. Not that it changes the value of the whole function, but it helps you to figure out the other trig functions, because now I know, since it's my 8 that is negative, my 8 in this case is my x value, which is my cosine. So my cosine is negative 8. Let me stop there and say, did that make sense? How I can say the cosine of t is negative 8, Crystal? Okay, good. Phew. Which means my sine of t is 15. My cosecant is the reciprocal, 1/15. Oh, goodness. Well, hang on just a second. Let me think about this a little bit more, because my secant and my cosine should be reciprocal. So this should actually be -8/17, which means, okay, so, which means this has got to be 15/8. So this is 8/15 there. So I'll show you this one thing that I think will help you understand what I just did, what I just discovered. So we know our tangent is y over x, which is the sine over the cosine. So 15/8 divided by -8/17 equal to 15/8 times, oh goodness, that's not going to come out either, is it? Times negative. Okay, let me hold the recording while I figure out what's going on so everyone else doesn't have to see me thinking about this, just you, Crystal. Okay, so we already have the cosine and its reciprocal function, the secant. We've got the tangent and its reciprocal function, cotangent. We're now going to use the cotangent to get the cosecant. So we'll use the cotangent value to get the cosecant using this identity up here at the top, relating cotangent and cosecant. And once we have the cosecant, we can just take its reciprocal to get the sine. So I'm just going to give myself a clean space to do this Pythagorean theorem work on. And let me just stick that to the board so it doesn't move all over the place when I write on it. Oops, of course it's going to act up on me this morning. There we go. I'll just try not to make it move around. Let me get my black pen. Okay, so we have the Pythagorean identity that the cotangent squared of t plus 1 equals the cosecant squared of t. And we already know our cotangent. Our cotangent is -8/15, and that squared plus 1 should equal the cosecant squared of t. Okay, so that is 64 over 225 plus 1. And I'm going to put the 1 over 1, and I'm going to come back and get a common denominator. That's 225 over 225. And that's going to equal the cosecant squared. So 64 plus 225 is 289. I think that's 17. Square root. 289 over 225 equals the cosecant squared of t. I'm going to take the square root of both sides. Yes, the square root of 289 is either positive or negative 17. And the square root of 225 is 15, and that equals our cosecant of t. We're dealing in quadrant 2, so sine and cosecant are both positive. So we don't need to consider the negative. So here we have the cosecant of t being 17/15, which means the sine of t is the reciprocal 15/17. All right, Crystal. Crystal got to see me turn off the recording and figure out where I was going wrong with all this. So Crystal, are you good now? Does that make sense how we found that? We actually had to use 2 of those Pythagorean identities. Okay. All right, as we discussed at the beginning of the chapter, a function that repeats itself, repeats its values in regular intervals is known as a periodic function. The trigonometric functions are all periodic because you can move through that circle as many times as you want to. Every one time you move through, you're moving 2 pi radians through the circle. So 4 pi radians is 2 full rotations, 6 pi radians is 3 full rotations, and so on. For tangent and cotangent, only half of a revolution will result in the same outputs. So a period is known as the shortest interval over which a function completes one full cycle. And we're going to learn a lot more about this when we start graphing these trig functions in Chapter 8. So what this definition says is that a period of a repeating function f is the number representing the interval such that, okay, so when I add that period to it, whether it's pi for or multiples of pi for tangent and cotangent, or multiples of 2 pi for all of the other trig functions, I get out the same function when I do so. So it's the difference in, let's say that's rotated pi over 4 radians. It's the difference in going pi over 4 radians and, okay, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. So pi over 4 is the same thing as 9 pi over 4. So that's what it's talking about. It doesn't matter how many times you go through the circle. If you're landing at the same spot, your function value is going to be the same. Is that good, Crystal? Okay. Okay, so really, talking about periodic functions there in your textbook was kind of strange to me because then they just leave the subject. I guess it was just kind of a sprinkling of the idea out there for you, but we will revisit that idea in a lot of detail once we get to Chapter 8. Here, we're just finding the values of the 6 trig functions like we've been doing this entire section. So sine t, cosecant t, cosine t, secant t, tangent t, cotangent t. Okay, so we're given the coordinates -1/2, -√3 over 2. So the sine of t is just the y value, which is -√3 over 2. The cosine is -1/2. The tangent is -√3 over 2 divided by -1/2, which is the same thing as -√3 over 2 times the reciprocal, -2 over 1. My negative times my negative is positive, my 2's divide out, so I just end up getting the square root of 3 there. Okay, the cosecant is the reciprocal of sine, so -2 over the square root of 3, I've got to rationalize. That's times square root 3 over the square root of 3, which gives me -2 square root 3 over 3. The secant is the reciprocal of the cosine, so this is just -2. And the cotangent is the reciprocal of the tangent, So that's 1 over the square root of 3. I have to rationalize. Square root 3 over square root 3 gives me square root 3 over 3. Now this 270-degree angle down here is very easy because you've got 0 and -1 to deal with. So sine t, cosecant t, cosine t, tangent t, secant t, cotangent t. Okay. The sine, okay, so we have the point 0, -1. So the sine is -1. The cosine is 0. The tangent is -1 divided by 0. You cannot divide by 0, so this is undefined. The cosecant is the reciprocal of -1, which is just -1. The secant is the reciprocal of 0, which is just 0. And the cotangent is the reciprocal of tangent, which is 0 divided by -1, which is also 0. Good on that? Okay. We're almost done. Okay, we've already actually done these. We did, that's a 45-degree angle, and we did that back here. We did it somewhere. We've done all those. I'm not going to waste your time doing them. We'll go ahead and look at this with your calculator. Okay, so evaluating a tangent function with a scientific calculator as opposed to a graphing calculator or computer algebra system is like evaluating sine or cosine. Enter the value, then press the tangent key. That's for a scientific calculator. On your graphing calculator, you hit the function button first and then put in whatever you're trying to evaluate there. You don't have a cosecant, a secant, or a cotangent button. So what you have to do is put them in their reciprocal form. So don't forget that cosecant of t is the reciprocal of sine. So that's 1 over the sine of t. So to find any of these reciprocal functions, the next one would be secant. That's just 1 divided by the cosine of that same angle. And then finally we have cotangent, which is 1 over the tangent of that same angle. Okay, so that's all you do is you put 1 divided by one of those first 3, sine, cosine, or tangent. Now, the thing that you have to be careful of is if you're given the angle in radians, which both of these are given in radians, you have to make sure that your calculator is set in radian mode. So your mode button is at the top center, and when you hit that, you just want to make sure for these 2 problems here that it is toggled onto radian mode, or you're going to get the wrong answers. Okay, so the cosecant of 5 pi over 7, also you want to make sure you're using your pi key and not rounding to 3.14. This is the same thing as 1 over the sine of 5 pi over 7. So when I put that into my calculator, I do 1 divided by, I hit my sine key, that's going to open up a parenthesis. 5, I literally use my pi key, divided by 7, end parenthesis. And let's see what we get. 1 divided by the sine of 5 pi over 7. I am getting that this is approximately, let me see what they ask us to round to. Let me go back out and look at our textbook. Very end. We are asked to round to the 3rd decimal place, it looks like. And I'm getting 1 0.279. Did you get the same thing, Crystal, in your calculator? Okay, great. So this next one, we have the cotangent of negative pi over 8. That's the same exact thing as 1 over the tangent of negative pi over 8. And when I put that into my calculator, make sure you're using your negative sign at the very bottom instead of your minus sign. I get approximately negative 2.414. All right, that's all I have for you for 7.4. Next week we'll pick up with chapter 8. Thank you for coming this morning, Crystal.